Hey, this is Jason Molesky. In this example, let's calculate a confidence interval for a population proportion P. Mr. Vignolini's class took a simple random sample of beads from the container and got 107 red beads and 144 white beads. Let's calculate and interpret a 90% confidence interval for P. Now, earlier we checked our conditions for calculating the intervals, so we know we're okay in doing so. And let's recall that our confidence interval will have the form statistic plus and minus a critical value times the standard deviation of the statistic. Or in this case, our statistic is p hat plus and minus a critical z star and our formula for the standard deviation of p hat. Now the sample statistic that we were given is 107 out of 251, or 0.426. To find the critical value, we can use table A by looking for the point with the area of 0.05 to its left. A 90% confidence interval, we use the area 0.05 to the left because we're trying to capture the middle 90%. 5% in each of the tails would leave 90% in the middle. Looking at the table, the closest value falls somewhere in here, which would be between negative 1.64 and negative 0.65. So using the calculator's inverse norm function, we can actually find it exactly at z equal negative 1.645, so we'll use that as our critical value. The resulting 90% confidence interval then will be our point estimate, 0.426, plus that critical z, 1.645, times the standard error of our point estimate, 0.426 times 1 minus 0.426 over our sample size of 251, for an interval from 0.375 to 0.477. So we can say we're 90% confident that the interval from 0.375 to 0.477 captures the true proportion of red beads in Mr. Vignolini's container. Now, let's say Mr. Vignolini claims exactly half of the beads in the container are red. Let's use the result from part A to comment on this claim. Well, since that confidence interval gives a set of plausible values for the population proportion of red beads, we'll want to check to see whether or not 0.5 falls in there. Because 0.5 is not contained in that interval, it's not a plausible value for P, so we do have good reason to doubt Mr. Vignolini's claim. For some additional practice in calculating a confidence interval for P, try exercise 35.